Dear students, welcome back to the chapter Surface Areas and Volumes. In this period, we will move on to the next lesson, Surface Area of a Cone. And again, the title of the lesson is not Surface Area of a Cone, it is specified right circular cone. Why the term right circular cone? We have seen it in cylinder. Similarly, in the cone also, we can have cones which are of this form, where the circular end is not straight, a slant circle. In such cones, we can't apply the rule that we are learning here. That is why it is specified right circular cone, which means the base and the height should be at 90 degrees to each other. So when we have a cone, the center of the cone should be 90 degrees with the height. So this is the height, this is the radius, and the angle is 90 degrees. One more term we have to concentrate while we work with cone, that is slant height. The height, if you can see that this is not a straight height, this is slant height, and it is represented by the letter L. And H is the straight height, the perpendicular height from the center of the cone, and that is represented by H. We may need it to find out the slant height at some point. And this is the radius. These are the parts that we have to know in a cone. And have you ever wondered how a cone is made? A cone is made up of a sector. You know, a sector is between two radii and the remaining part of the circle, with a corresponding circle which has the circumference which is equal to the distance from one end of the sector to the other end. If this measurement is, let's say, 10 centimeter, so we have to find a circle whose circumference is 10 centimeter. Such a circle, when you attach here at the base, we will get a cone. Now, how to find the curved surface area of a cone? The curved surface area of a cone, it is actually from this sector, and this sector can be considered as many triangles. So we can apply the area of a triangle, and you know the area of a triangle is half times base times height. So slant height times circumference of the circle, which is 2 pi r. You can cancel 2 and 2. So finally, the curved surface area of a cone is L times pi times r, or pi r L. This is the curved surface area of a cone. Now let us see the total surface area. So we have seen only the curved surface area, which is the sector. So total surface area will be sector plus the circle. So it is pi RL plus pi r square. And we can simplify this one by taking pi r common. We have pi r and pi r. When you take pi r common, we have r here extra and L here. So total surface area of a cone is pi r times r plus L. And curved surface area of a cone is pi r L, which can be compared with total surface area and curved surface area of a cylinder. Do you remember? Just for a quick review only, total surface area of a cylinder is 2 pi r plus h. So here we can see pi r is there. This is r plus h, and here it is r plus L. And remember, there is no 2 here. And at the same time, curved surface area of a cylinder is 2 pi r h. So instead of L in the cone, we have h, and also we have 2 in cylinder. Just a comparison so that you are not confused. Moving on to the exercise. Diameter of the base of a cone is 10.5 centimeters, and its slant height, which means L, we are given L. So diameter we have, but we need radius. So radius is equal to 10.5 divided by 2 centimeter. And the slant height, you have to be careful. Are they giving you slant height or height? So this is slant height, which is equal to 10 centimeter. Find the curved surface area of the cone. That is the question. And first of all, we will write the rule pi r L. So here we have the slant height is 10 centimeters and the radius is 10.5 divided by 2. Both of them are in centimeters. So let us apply. And we are asked to use the value of pi is 22 by 7 times radius is 10.5 divided by 2 times the slant height. This is 1.5 and this is 11. So we have 11 times 15, 165 centimeters square. That is the curved surface area of the given cone. Let's see the next question. Find the total surface area of a cone if its slant height. Once again, slant height is given to us and it is in meters, and diameter of the base is 24. So we have slant height is 21 meter, diameter is 24, so radius is 12 meter. Simple, we just have to apply the rule for total surface area of the cone is pi r plus L, which is equal to 22 by 7 times 12 times 12 plus 21. 22 by 7 times 12 multiplied by 33, which is 1244.57 meters square. Very simple question just to apply the total surface area of a cone. Next question. Curved surface area of a cone is 308 centimeters square. So we are given the curved surface area of a cone, which is pi RL. So we have pi RL is equal to 308 centimeters square. Slant height is 14. So L is equal to 14, again in centimeter. Find the radius. So first question is radius. So we can apply here 22 by 7 times radius times 14 is equal to 308. We can simplify. R is equal to, this will give us 44. 308 divided by 44. Therefore, radius is equal to 7 centimeters when you simplify this. Next question is total surface area. Just we apply the rule for cone, which is pi r plus L. Radius is 7. 7 plus slant height is 14, which is equal to 22 multiplied by 21, 462 centimeter square. Because it is area, it will be with square. Very easy exercise. Question 4. A conical tent is 10 meter high. This is not slant height. So h is equal to 10 meter. Radius is 24 meter. Find the slant height. So we have to find L. For that, we have to consider a right triangle with height is h, radius is 24, r, which is represented by r, and slant height L will be the hypotenuse. So let us consider a right triangle with radius 24 meters, height is 10 meter, and this is missing. So by Pythagoras theorem, square of the hypotenuse is equal to sum of the squares of the other two sides, which is 100 plus 576, therefore, which is equal to 676. Or L is equal to, when you take square root on both the sides, we will get 26. Therefore, slant height is equal to 26. Part 2. Cost of the canvas required to make the tent if the cost of 1 meter square of canvas is 70. We need only the curved surface area because canvas will not be on the base of the cone. So curved surface area of the cone is pi RL 22 by 7 multiplied by 24 times 26, 13,728 divided by 7 meter square. Therefore, cost is equal to 13,728 divided by 7 multiplied by 70, because 1 meter costs 70, so the whole unit will cost 13,728 divided by 7 multiplied by 70. This can be simplified. So the total amount is 1,37,280 rupees. Moving on to question 5. What length of tarpaulin 3 meter wide will be required to make conical tent of height 8 meters and radius 6 meters? So first of all, we have to consider a tent of height. Slant height is not given to us. Height is 8 meters and the radius is 6 meters. So we have to find L first. And then we will check what is the detail about the tarpaulin. So first of all, by Pythagoras theorem, L square is equal to 6 square plus 8 square. So L square is 36 plus 64, which is 100. So slant height is square root of 100, which is 10 meters. So we have the details about the tent now. Now assume that the extra length of material that will be required for stitching margin and wastage in cutting is approximately 20 centimeters. So we have to consider extra 20 centimeter at the end. It is a tent, so we have to consider the curved surface area of a cone pi RL, which is equal to, but here we are asked to use 3.14. 3.14 multiplied by the radius is 6 multiplied by the slant height is 10, which will be 3.14 multiplied by 60, 188.4 meter square. That is the curved surface area. This area is supposed to be taken from a tarpaulin which is rectangular in shape, and the width of the rectangular shape is 3. So we have to find a total area 188.4 from a rectangular sheet, and the area of a rectangular sheet is breadth multiplied by the length, and we don't know what is the length of the rectangular tarpaulin. So we can find the length is equal to 188.4 divided by 3, which is equal to 62.8 meter square. Now we are also asked to add an extra 20 centimeter. Therefore, total tarpaulin required is equal to 62.8 plus 20 centimeter, which is equal to 0.2 meter. So which is equal to 62.8 plus 0.2 is 63 meter. This is the total tarpaulin required. Let's see question 6. The slant height and the base diameter of a conical tomb are 25 and 14. So slant height, L is 25 and diameter is 14. So radius is 7. 25 and 7. Find the cost of whitewashing its curved surface at the rate of 210 per 100 meter square. So first we will find the curved surface area in meter square. Curved surface area of a cone is pi RL, and we can use pi is 22 by 7 because it's not given to use 3.14 multiplied by 7 multiplied by 25, which is equal to 550 meter square. We have 100 meter square is 210 rupees. So 1 meter square is 210 divided by 100, which is rupees 2.10. This is for 1 meter square. Therefore, for 550 meter square, total cost is equal to of whitewashing is equal to 550 multiplied by 2.1, which is equal to rupees 1,155. This is what you get when you multiply these two numbers. Let's see question 7. A joker's cap is in the form of a right circular cone of base radius 7 centimeters and the height is 24. So first we have to find L using Pythagoras theorem. Height is 24, 7 and L. So by Pythagoras theorem, L square is equal to 7 square plus 24 square. So L square is equal to 49 plus 576, which is 625. Therefore, L is equal to 25 when you take the square root on both the sides. Now the cap, of course, it will be the curved surface area because the base will not be closed. Curved surface area of a cone. Once again, we apply pi RL. We are not asked to use 3.414, so 22 by 7 multiplied by 7 multiplied by 25, which will be again 550 centimeters square between 22 and 25. Such 10 caps are supposed to be made. Therefore, area of sheet for 10 such caps is equal to 550 multiplied by 10, which is 5,500 centimeter square. Now to the last question of this exercise. A bus stop is barricaded from the remaining part of the road by using 50 hollow cones made of recycled cardboard. Each cone has a base diameter of 40, so radius is 20 centimeters. And the height, we are not given slant height, only height is 1 meter. So radius also to be in meters, so 0.2 meters. And we have to find L. If the outer side of each of the cone is to be painted and the cost of painting is 12. So first of all, we need to find curved surface area because we are only painting the curved part. So we have to find L. By Pythagoras theorem, L square is equal to 0.2 and 1 meter. So 1 square plus 0.2 square. So L square is equal to 1 plus 0.04. Be careful because 0.2 square is 0.2 multiply 0.2 is not 0.4, it is 0.04. So L square is equal to 1.04. So when you take square root, we are given square root of 1.04 is 1.02. So we get the slant height. Now we have to find curved surface area. Curved surface area of the cone is pi RL, and we have to use 3.14. 3.414 multiplied by radius is 0.2 multiplied by slant height is 1.02. Area to be painted is equal to 0.6406. So total area of 50 such cones will be 50 times 0.6406, which is approximately equal to 32.03. Therefore, total cost of painting all these 50 cones is equal to 32.03 multiplied by, for 1 meter square, it is 12 rupees. So we multiply by 12, approximately rupees 384.36. That's all for today. Thanks for watching.